So this is lecture 4.3, Systems of Linear Equations and Problem Solving or Applications. So basically I think I've got about 5 applications from the book, and you'll see how easy some of these are to solve when we have the power of linear equations and systems. So right here, let's look at this graph right here. Now clearly this red line is not the graph of a straight line. However, if you take statistics, we can actually do a linear regression on this. Actually, we can give a line that is the best fit to all of these points, and it will be a straight line, and it will have negative slope because it'll be going down here. And the same is true for the poultry. We assume that it can be approximated by a linear function, and statistics allows us ways to create the best fit linear function to these given number of points. And this is actually what they've done. So the red line deals with red meat, consumption of red meat, meaning I guess beef, cows. There's more than that, I know, and poultry. So let's just read the problem. So America's consumption of red meat has decreased most since 2005, while consumption of poultry has decreased also, but to a lesser amount. So the function y equals minus 2.03x plus 119.05 approximate the annual pounds of red meat consumed per capita, where x is the number of years since 2005. So what they've done is this function y equals minus 2.03x plus 119.05. That's y is equal to mx plus b. And here we see that our slope is negative. So they've actually used a type of curve fitting, in this case it's a line, to approximate it. And they've done the same thing with poultry. And they came up with the equation y is equal to minus 0.41x plus 103.21. And that approximates the annual pounds of poultry consumed per capita, where x is also the number of years since 2005. So our x-axis is years, and we just start at 2005. That's our 0 point. And our y-axis is pounds. How many pounds? Annual pounds of red meat, where x is the number of years, annual pounds per individual. Per capita, so it's per individual. That's a lot of meat per individual. So what we're going to do, we're asked to find what year the annual consumption of red meat and poultry is equal. So again, especially from our last test, we're not going to use calculators. Simple, basic math, addition, subtraction, multiplication, and division is the cornerstone of mathematics. We cannot allow calculators to take that over. But what we are going to do, because when it does take it over, none of you have any idea. It was very evident for me on our last exam that very few of you, I think there's maybe 1 or 2 exceptions, have any idea how to do decimal multiplication, much less division. But in this case, what we're going to do, we're going to look at our 2 lines, the 2 equations given, and the top will be for meat. Maybe I should write it in red, but I'm not. Y is equal to minus 2.03x plus 119.05. This indeed is a calculator problem, but we're not going to use calculators. Poultry, I'm trying to think how to spell poultry, P-O-U-L-T-R-Y. That's given by y is equal to minus 0.41x plus 103.21. So what we're going to do is we're going to approximate. So we're going to round the numbers here to the nearest tens. So 119.05 is going to be approximated to 120, and 103.21 is going to be approximated to 100. So what about approximate to the nearest 10 as far as the numbers greater than 0? And for these with decimals, we're going to approximate to the nearest 1/10. So that means minus 2.03 is just going to be approximated to minus 2. And minus 0.4, is it 0? There's an X there. I didn't write that down right. I think it's 0.41. Yep, 0.41. Let me write that as 41, not two X's. 41. 0.41 is going to be approximately equal to minus 0.4. But I'm not going to use decimals here. So this is 4 negative 4/10, minus 4/10, because that's the 10th place. So I'm going to just reduce that to minus 2/5. So I'm going to go ahead, and now with these approximations, that's close enough, and it makes it much easier to do without a calculator. So I'm going to put my first equation, y is minus 2, it's a minus 2x plus 120. In my second equation, y is equal to minus 2/5 x plus 100. And what is the first thing I'm going to do now? I don't want to deal with decimals, so I turned it into a fraction. And now I don't want to deal with fractions. So for number 2, I'm going to rewrite differently. For number 2, this equation, I'm going to multiply both sides by the denominator. So number 2, and you don't have to put these little asterisks here, becomes 5y is equal to 5 times minus 2/5 x is minus 2x plus 500. So that's going to be my linear system I'm going to deal with. I'm going to rewrite them here. So I have two equivalent linear systems. Y is equal to minus 2x plus 120 to y, 5y, is equal to minus 2x plus 500. And I'm going to do the elimination method to solve this. So what I'm going to do is write these linear equations in the form ax plus by is equal to c. So 1 is going to be, I'm going to move the minus 2 over, so it's going to give me 2x plus y is equal to 120. Now I'm going to move the minus 2x over again. I'm going to have 2x plus 5y is equal to 500. So here's what I want to do. Notice our coefficients are the same. So I'm going to focus, since the coefficients of our x term are the same, when I do vertical addition, and that's what I'm aiming for, vertical addition to eliminate my x term, I'm going to multiply number 2 by minus 1. Everything by minus 1. So when I do so, everything becomes negative. So I have minus 2x minus 5y is equal to minus 500. So now we're going to do vertical addition. 2x minus 2x is 0x, so you don't have to write down 0x. Plus y minus 5y is minus 4y. And 120 minus 500 is the same as 500 minus 120, and that gives me minus 380. So I'm going to go ahead and multiply. So this 0x, it's just annoyance. It disappears. So what I'm going to do is I'm going to go ahead and multiply both sides through by minus 1. So that gives me 4y is equal to 380. And now don't go grabbing your freaking calculators. Let's divide now both sides by 4. This is an easy division. So 4 divided by 380. Well, 9 times 4 is 36. 38 divided minus 36 is 2. Bring down the 0 is 20. 4 times 5 is 20. So I have remainder 0. So y is equal to 95. So I already found one of my ordered pair solutions, 95. That's going to be 95 pounds. Now the next thing I'm going to have to do is solve for x. Now that I know what y is, this is a really important solution. I just go up and I choose any of my equations in any form. It doesn't make any difference. And I use my value for y to solve for x. And I'm going to choose number 1. So we have 2x plus y, but y is 95, so this is the one I'm looking at, is equal to 120. So let's go ahead and solve. So bring the 95 over. So 120 minus 95 is 25. Now I'm going to divide both sides through by 2. And x is equal to 25 halves. So x is equal to 25 halves. But remember, of course, if they want to know what year that's in, then our years start off at the year 2005, and 25 halves is 12.5. So we add 12.5 to it. And in 2017, around the midway point through the year, sometime in June, is when it will actually the two consumptions of the meat and the poultry will be the same. But this is going to be the solution. You'll have to look at if my math lab gives you this problem, you will have to look and see what they want for your ordered pair. Whether they just want the number of years since 2005, or they actually want the actual year, in which case you have to add. It's easier just to convert 25 divided by 2 into a decimal and add it to 2000. So let's actually take a look at that using GeoGebra. So here I have my first equation. Y is equal to minus 2x plus 120. So there is that line graphed. And my second equation was 5y is equal to minus 2x plus 500. And right there, that is the second line. And there's clearly the intersection point. And when I look at the intersection point A, it gives me the answer, of course, in decimal, 12.5 comma 95. So that's a way of checking that the answer I got was correct. Okay, so let's move on. So our next one is another applied problem. So let's read through the problem first. A first number is 4 less than a second number. 4 times the first number is 6 more than twice the second. Find the numbers. So we have to decide on variables. So let's go ahead and let x equal the first number. And clearly y will be the second. So now let's translate each sentence in turn. Our first equation. A first number, which is x, is 4 less than the second number. That means y minus 4 is equal to x. What's my second equation? 4 times the first number, so 4 times the first number is 4 times x, is translates into equals 6 more than twice the second. So twice the second is y, and when I add 6 more to it, I get 2y plus 6. So right here I have a system of linear equations. So let's go ahead and use the method of substitution rather than elimination. Why do I want to do this? Because I already have x in terms of y from equation 1. So let's go down to equation 2, and 4 times x, well, x is equal to y minus 4, is equal to 2y plus 6. So that's 4y using distribution. 4 times minus 4 is minus 16, is equal to 2y plus 6. So I'm going to move my 2y over here. It's going to change its sign. And then I'm going to move my minus 16 to the other side, and it's going to become 16. So 4y minus 2y is 2y. And 16 plus 6, don't grab your calculator. That is 22. So now let's divide through both sides by y. So that gives me y is equal to 11. So I've got one portion of my ordered pair solution, and that is 11. So how do I find x? I need to find x. Well, this is the easiest. Literally, I could use either equation 1 or 2, but this is much easier. X is equal to y minus 4, but y is equal to 11, and 11 minus 4 is equal to 7. And right here, we have our ordered pair solution of these two linear equations. So that one was really easy, right? That's what you want to see on the exam. Well, of course, the good thing on the exam is the plan is for this one is going to be a little bit different. I haven't actually written it yet, so I'm going to stay quiet. And I plan on using some of these lectures for future classes anyway, not just the class that's meeting in fall of 2020. So I'll be quiet about that and just send you the information on that in an email or announcement. So here we go. Here's another one. So let's read the problem. So 2 cars leave Indianapolis, one traveling east and the other west. So listen, if you all want to draw a sketch, draw a sketch. Car 1 is going east. We'll call that car 1. And car 2 going left, and right there is Indianapolis. If that helps, then do it. After 3 hours, they are 297 miles apart. If one car is traveling 5 miles per hour faster than the other, what is the speed of each car? So we're going to let x, I don't want to use red, let's let x, so x, our unknown is speed. X equal to the speed of car 1. So it means y will equal to the speed of car 2. So the distance, let's think of another thing we have here. So what is the total distance? So let's get some more here. Some more room. So the distance, d, the total distance is given to be 297 miles. So if that's their end point and that's their end point, the distance between them, the total is 297 miles. And what else does it tell us? After 3 hours. So the total time is 3 hours. So what do we know about the relationship between distance, time, and speed? Well, speed, I'm using the variable x, is equal to distance over time. So speed is given by the variable x here. Why? Because I say right there, x is the speed of car 1. So x is equal to distance over time. So let's think of another relationship. The distance of car 1 plus the distance of car 2 is equal to 297. So what is the distance? X times t is equal to the distance. So the distance of car 1 is equal to, well, the time is 3 hours times the speed of car 1 plus 3 hours times the speed of car 2 is equal to 297. And what else do I know? If one car is traveling 5 miles faster than the other, what is the speed of each? So I'm just going to say x will be equal to the speed of y plus 5. So that means x is going to be the faster of the cars because it's going 5 miles faster than car 2, faster of the cars. Now, of course, my drawing here suggests that maybe they're moving at the same speed, but that's just, we don't want to put too much into the drawing. It just helps us get things like distance, the total distance, and the total times. So right here I have my system of equations. So let's go down here and write them nice and neat. 3x plus 3y is equal to 297. And then I have x is equal to y plus 5. So here I want you to think for a second. We have two methods to solve this. Which do you think is the best one? Now both work, but I'm going to suggest the substitution method is the best because I already have x in terms of the variable y. So I'm going to go up here and we're going to replace 3. So I'm going to start with equation 1 and replace x with the value given in equation 2. So 3 times x, well, x is equal to y plus 5 plus 3y is equal to 297. So now it's just a matter of solving a simple linear equation. So that's 3 times y, and 3 times 5 is 15, plus another 3y is equal to 297. Now I'm going to collect like terms on my right-hand side first. That gives me 6y plus 15 is equal to 297. So that's 6y is equal to 297 minus 15. So 6y is equal to 282. So let's go ahead and divide through by 6. So y is equal to 282 divided by 6. Now, is there any way you can know if 282 is evenly divisible by 6? Yes, there is. The divisibility by 6 test is the following. If the number is divisible by 3 and the number is divisible by 2, then it is divisible by 6. Why? Because 6 is 3 times 2. So we know that 282 is divisible by 2 because it's an even number. What about divisible by 3? What's the test for that? We add up the digits. 2 plus 8 is 10. 8 plus 2 is 12. Is 12 divisible by 3? It is. So that means 282 is divisible by 3. So let's do the division. We know it will be an even number. So 6 times 4 is as close as I'm going to get to 28. So that's going to give me 24. So 28 minus 24 is 4. Bring down the 2. And 6 times 7 is 42. So my y value is 42. So now that I've got my x value, so that's equal to y. So now that I've got my y value, let's get our x value. And literally, you could use any equation you want, but to use anything other than this would be silly, because x is equal to y plus 5, but y is equal to 42. It is 40, sorry. I'm saying 42. I don't know why I'm saying 42. I have 47 written down. Oh, that's the reason I'm saying 42. Y is equal to 47. This number right here. So y is equal to 47 plus 5, which is equal to 52. So there's my ordered pair solution. And you could check it. You could visually check that if you have a program that graphs equations. Okay. Next one, very similar to the traveling problem. So we're going to have to use this. I give you a little hint here. Maybe I should make this bigger, sorry. So the number of liters times solution strength is equal to the amount of pure solution. So a pharmacist needs 70 liters of a 50% alcohol solution. She has available a 30% solution and an 80% solution. So how many liters of each solution should she mix to obtain 70 liters of a 50% solution? So we've done this one before in a similar right, but I think in that case we're mixing both of them. In that case we had 1 liter and we were mixing in another and diluting it, or we had one solution and we were mixing it into the other and increasing the strength. So in this case we have to decide on our x values. So let's let x be equal to how many liters? So liters of our 30% solution. And let's let y be equal to the number of liters of our 50% solution. So these are liters. So what do we know? One equation is immediately apparent. When I mix them together, the liters of x plus the liters of y, I've got to get 70 liters. That's the 70 liters right here. But I also know that the number of liters times the solution strength equals the amount of pure solution. So that gives me 30%, so that's 30 divided by 100 of the x liters, plus 50 divided by 100 y, gives me how much? Oh, it's an 80% solution. Sorry. %80 solution. Sorry about that. And that's going to give me a 50% solution of my 70 liters. Sorry about the typo there. I just looked at the wrong place to grab the number. So what are we going to do with this? First thing I'm going to do is I'm going to rewrite number 2. What am I going to do to rewrite number 2? I'm going to multiply every part of it by 100. So 100, I'm multiplying the entire, each side by 100. So the denominators are going to clear, and that's going to give me 30x plus 80y is equal to 50 times 70. And I'm actually going to do one further simplification of 2. Yet another version of 2. Since each of these 30 and 80 and 50 is divisible by 10, I'm going to divide each side by 10. So that's going to give me 3x plus 8y is equal to 5 times 70. Or in other words, 3x plus 8y is equal to 350. So here I have my system after simplification of linear equations. I have linear equation 1, x plus y is equal to 70. Equation 2, 3x plus 8y is equal to 350. Here I could multiply the top by minus 3 and we would be just fine. But let's go ahead. I have a feeling you're more comfortable, it's just a feeling and intuition, that you're better off with the substitution method. So let's solve for x. So x is equal to 70 minus y. That comes from equation 1. So looking at equation 2, now with equation 2, I'm going to just go ahead and wherever I see x, whoops, I lost my information, I'm going to plug in 70 minus y. And that's going to give me 350. So 3 times 70 is 210, and 3 times minus y is minus 3y, plus 8y is equal to 350. So let's collect like terms first. 310 minus 3y plus 8y is 5y is equal to 350. So now I'm going to move 210 on the other side. it becomes negative. So I have 5y is equal to 140. And isn't the nice thing about this is I know I don't have to have a calculator because 140 ends in 0, so it's divisible by 5. So 140 divided by 5 will go twice. That's 10, 40, and 0, and that gives me 8. So my y value is 28. What is my x value? Well, x is equal to 70 minus y. So x in this color, x is equal to 70 minus y, which is equal to 70 minus 28, which is equal to 42. So we need 42 liters of my 30% solution and 28 liters of the 80% solution. I think that's much easier than the other way that we do it, to be honest with you. Okay, one last business-related problem, and we'll be done with this lecture. So cost and revenue. So let's just read this together. Recall that businesses are often computing cost and revenue functions or equations to predict sales, to determine whether prices need to be adjusted, and to see whether the company is making or losing money. So your revenue must be greater than or equal to your cost. The revenue is the money you take in, and the cost is the money you spend. So the revenue has to be greater than or equal to your cost for the break-even point. And this tells you that right here. The value at which revenue equals cost is the break-even point. When revenue is less than cost, the company is losing money. When revenue is greater than cost, the company is making money. And you might read, if you're business-oriented, you might read startup companies that have been losing money for their first 3 years. And you say, how do they continue? Why are they continuing? Because they've literally plotted out the revenue and the cost function, and they can look at the future and they say, okay, in 5 years we're going to start making money, and from that point on we're going to increase and increase and increase, and in 5 years we're breaking even. In 7 more years we've actually made up all the money we've lost, and we keep doing better and better from there on. So it's a money-related thing. So in this case, a manufacturing company recently purchased $3,000 worth of new equipment to offer new personalized stationery to its customers. The cost of producing a package of personalized stationery is $3, and it is sold for $5.50. Find the number of packages that must be sold for the company to break even. So revenue for selling X items is equal to price per item times number of items. So I gave you a hint there. So we're going to call, remember, in function notation, R of X and C of X, both of those are equal to Y. No matter what our function definition is, Y is equal to F of X, or R of X, or G of X. Anytime you have the function notation, you can replace it by Y. And the little bitty hint that I gave you, way down here, and I can't really, I can scroll up. I thought it was the last page and I wouldn't be able to. So our revenue, so let's write out our revenue. Well, what is our X value? Our X is going to be find the number of packages. So it's the number of items. In this case, those items are packages. But in general, it's the items sold, the number of bushels of corn, the number of crates of oranges. So R of X, right here, is equal to the price per item times the number of items. Well, the price per item, this is our revenue, how much you sell it for, is $5.50. $5.50 times the items. And our C of X is going to be our cost function, where our cost function starts with the base cost, which was given to be $3,000, plus $3 per item. So we want to know when does Rx equal Cx? And literally we're going to solve this in another way. We could have been solving all of our it's another way to solve linear systems, but we're going to use that method, and I'm not going to mention it any further. I thought about doing it, but I'm just going to simply solve this equation. When is Rx equal to Cx? So let's do it. I want to know when 5.5x is equal to 3,000 plus 3x. And I'm solving for x. So once I've got my equations, I just set them equal to each other. So what am I going to do? I'm going to move my 3x to the other side. It becomes negative. So 5.5x minus 3x is 2.5x is equal to 3,000. But 2.5 is the same as 5 halves. So that means 5 halves x is equal to 3,000. So what I'm going to do, I'm going to multiply both sides by 2. So that's going to give me, no, not that one, multiply both sides by 2. That's going to give me 5x is equal to 6,000. And now all I have to do is divide both sides through by 5. 6,000 divided by 5. Well, 5 will go into 6 one time. 10, 2, and we're done. X is equal to 1,200 items. And what are our items? Those are packages. And I think that's our last one. Yeah, that's the last one.